In this tutorial, we will model a column slab joint at SOLIDO. The concrete slab dimensions are 200 by 200 centimeters, with a thickness of 20 centimeters. Over this, we have insulation of 10 centimeters thick. A column plate supports the slab at the bottom, and columns at the top and bottom of the slab have dimensions of 30 by 30 centimeters. We now open a new SOLIDO project and will model this geometry with the origin at the middle of the floor, so that column which will be added later will also be at the center. We start by changing the color to 136 for concrete. We then modify the black point to -100 in X and Y direction. Then, +100 for gray point in both X and Y directions. Here we change the Z value to have a height of 20 centimeters. Now we need to insert the insulation on top of the slab. So, we click on the block representing the slab and choose Insert After. This creates a new block below. We change the color to 133 for insulation and modify the block coordinates of X and Y, to be similar to the slab, which is -100 for black point and +100 for gray point. Lastly, change the Z coordinate from 20 to 30 as the thickness of the insulation is 10 centimeters. Now we notice the insulation is placed over the slab. Here insulation starts from Z equals 20 and ends at Z equals 30. We also see that the grid is decoupled from the blocks as we discussed in the previous video. Now we will add the plate below the slab. Click on the last block and then choose Insert After. We get a block with default block points. We now change the black point coordinate to -45 in X and Y directions, and +45 for gray point in both X and Y directions. For Z, we input -10 as the thickness. Instead of creating new block by choosing to insert before or after, we will explore other tools to create a new block. Select the block which you wanted to duplicate and then from the Blocks menu choose Copy After. We create a copy of the block with the same coordinates as that of the plate. If we had chosen to create a new block, the block point coordinates would be with default values. We change the color to 136. Let's visualize the geometry at an orthogonal view, say perpendicular to Y direction. We now will move the duplicated block. Select the block and click on the drag block icon. Now at the status bar, we see the prompt to guide us further. So, if we hold Ctrl, movement will be locked to move only on the Z direction. We now drag the block down holding Ctrl by clicking on a reference vertex and snapping it to the new point. Then we need to change the thickness, so we change the Z coordinate from -20 to -40, creating 30 centimeters thickness downward. Now we add a column by inserting a new block below and change the view to perspective. Then modify the block point coordinate of the black point to -15 in X and Y direction. Then gray point to 15 in X and Y, and we input the height at Z direction to 100 centimeters height. If we want to extend the column below, we change the Z value of the black point to -100. We will correct the default color of the newly inserted block to concrete, which is 136. We need to create a sloped chamfered surface for the column plate. We select the block representing the plate and we notice that it's not possible to create the shape we need with just 2 block points. Hence from the Blocks menu, choose Make Hexahedron. Using hexahedron, block points are created at all the vertices. So now we can either change the coordinates of the points we wish to move, or we can move the point by choosing Drag Point icon. It's easier to move or drag at orthogonal view. So, we change the view perpendicular to Y-axis and then click on Drag Point. We can read the status bar for further guidance. We now can move the block point by selecting the point and holding Shift to lock the movement along the X-axis and snapping it to the column intersection. There is also another block point behind. We move it in a similar way to intersect with the column. We now have completed one side of the plate. Similar procedure has to be performed on the other side. Then, we should rotate our view orthogonally, which is perpendicular to the x-axis. Here, using the same procedure to move the block points, both sides snapping the column must be performed. Once geometry is created, we now need to create boundary conditions. We will make use of the principle of superposition. We create boundary conditions with the lowest priority so that blocks representing geometry will override them at the area of intersection. We click on the first block and then choose Insert Before. We similarly create another block as we need 2 blocks for 2 boundary conditions. We override the colors as 174 for the interior boundary condition and 170 for the exterior boundary condition. Let's consider the indoor boundary is on top of the slab and the outdoor is at the bottom. For block with color 174, we need to move the black point up by 30, so z is plus 30 and x and y points are minus 100. Then for the block with color 170, we will move the gray point down at z direction to minus 100. Then for the black point we change the x and y coordinates to minus 100. Once we create all the required blocks, we click on Fill to triangulate the meshes. If we choose Display Preview as boundary conditions, we can see indoor in magenta, outdoor boundary conditions in blue and adiabatic boundary conditions as yellow. So far we haven't updated grids. Thermal calculations are performed for the generated grid meshes. As a last step after creating the geometry, we will now learn how to create grids. Firstly, from the Grids menu choose Minimum Grid. SOLIDO generates a minimum grid based on the block points. Again, from the Grids menu choose Link Block Points to Grid. By choosing this, if we update the grid dimensions, then automatically the block points will also update. Say we want to change the insulation thickness from 10 to 30 centimeters, we notice block points are updated automatically. Suppose we turn off Link Block Points to Grid, and then again update the grid representing the insulation thickness. The grid is changed but the block remains unaffected. You can undo this by Ctrl-Z. However, linking block points to grid is only an optional step if in case you want to link the changes automatically. If you turn on Link Equal Points, then overlapping block points are linked to each other. If we wanted to select the slab, you can either choose the block representing the slab from the blocks window or right-click on the slab at the display window. Once the slab is selected, reduce the slab thickness to 10 centimeters, by changing Z to 10. Now click on Fill icon to triangulate the meshes. We notice the insulation block is automatically extended as the slab reduces its thickness. Here the equal block points are linked. But then, the grid is not updated as we turned off Link Block Points to Grid. We hope the difference between Link Block Points to Grid and Link Equal Points are clear with this example. In this tutorial, we learned how to create geometries within SOLIDO. In the next tutorial, we shall learn how to generate calculation meshes for the geometry. Thank you for watching, see you in the next video.